There had been hundreds of stories and theories to explain the aurora. But no one suspected a connection with the sun. An eccentric Norwegian scientist, Christian Birkeland, built his own world in a glass box. Electrified his model Earth with its own magnetic field and showed how electrons from the sun could ignite earthly auroras. And he predicted that they would be identical and simultaneous at both poles. Birkeland was right, but proof of his theories and so much else had to wait until we could step into space. Space has given us new eyes. Everything we glimpsed before can be seen anew. A stormy night as we fly towards the coast of Australia. We're heading south, out over the Southern Ocean, towards Antarctica. This is Soho, built in England and France for the European Space Agency, with instruments from Europe and the USA. It was launched by NASA and parked 1 million miles from Earth, at a point where the gravity of the Earth exactly balances the gravity of the Sun. Soho shows us the Sun as we've never seen it before. Wider lens. The image is 30 million miles wide. The sun blanked out so we can see the corona jetting out into space. Here the two images are combined. Billions of tons of particles fired into space at 1 million miles an hour. Sometimes directly at our Earth. We are saved by our magnetosphere, an invisible magnetic shield that protects us from the lethal particles that are spewed out by our sun and other stars. This solar storm pushed the edge of our magnetosphere twice as close to Earth as usual, disabling satellites, wiping out radio communications worldwide, and sending voltages soaring dangerously in everything from power transformers to oil pipelines. Repairs after the last solar maximum cost more than $1 billion. A century ago, space storms could pass unnoticed. But 2,000 satellites have been launched since the last solar maximum. Every aspect of our civilization depends on their uninterrupted functioning. Sunstorms can kill satellites. They can also kill astronauts. For long space flights, a dangerous storm is a practical certainty, and finding effective protection a necessity. But at present, the best we can do is try to avoid solar maximum. The Sun has north and south magnetic poles, just like the Earth. But every 11 years, those poles reverse with unimaginable violence. That peak of violence is called SolarMax. The 11-year cycles can change, even vanish completely. About 1,000 years ago, the Sun was unusually active. It was about the time the Vikings settled a grassy new land they called Greenland. Thousands moved there. But then the Sun grew quiet, and the solar cycles almost stopped for 100 years. The average fall in temperature was just 2 degrees, but it was deadly enough. The bays froze over. The people starved. No one survived. Recently, scientists have found that suns like ours normally produce a superflare about once every century. A superflare would destroy half of our ozone layer and the entire satellite fleet. We're fortunate that our sun seems to be much more stable than most other suns. A tiny new spacecraft called TRACE brings us a view of the sun that is still largely beyond the scope of our understanding. Magnetic field lines burst through the surface to unleash in seconds as much energy as the world uses in 1,000,000 years. On the horizon is the mountain that Native Americans call the pivot of the sky. This is Kitt Peak in Arizona, site of the National Solar Observatory. The small telescopes on the spacecraft work in harness with large telescopes on Earth. The combination produces results that are much more valuable than any of them could obtain alone. This is what we call the surface of the sun, the layer revealed by visible light. Embedded in it are 2 sunspots, each big enough to swallow the Earth. With filters and computers, we can peel away the layers as we turn the pages of a book, searching for a better understanding of the forces that shape our universe, and more urgently, that shape the climate of our world. We urgently need to know more. So an international solar terrestrial program was devised, linking satellites and a chain of observatories to create one great observatory. A surprising discovery was the singing of the sun. As the sun hums to itself, 1,000,000 pure tones change as they resonate through the plasma, revealing to us tides and currents far below. In a Munich laboratory, final testing of a satellite that is destined to be flown into the eye of a solar storm. It is one of 4 identical spacecraft designed to fly together in formation to capture a unique 3D picture of the space environment. The formation encloses a pyramid of space and monitors everything that happens inside that space. The tiny fleet will give us an unprecedented view of the interaction of the solar wind with our magnetosphere, from the bow wave to the distant tail. As the millennium approached, everything was in place to make the SolarMax of 2001 a milestone in our search for understanding of the sun. But a mistake was made in a command sent to Soho. In a split second, Soho went from being the flagship of a space fleet to a useless piece of frozen junk. The Soho team refused to give up. From all over Europe and the USA, they rushed to the control center at NASA to brainstorm ideas, working to save their ship. Months passed. Dozens of schemes were tried. It was like trying to raise a submarine with a fishing line. But against all the odds, a signal hooked into the control computer. Delicately, painstakingly, tiny surges of solar power thawed out fuel for the thrusters. Incredibly, the whole array of critical instruments proved tough enough to survive being frozen solid for 3 months.
Looks like they've done it.
Soho came back from the dead.